Okay. Now, in case of aptitude, right? So the most important thing, right? आपने सुना होगा aptitude होना चाहिए, आपको आना चाहिए, and all those things, right? Must be going on in your mind. You must have heard it somewhere here, there. But whenever you listen to aptitude, just remember two things. It's a combination of mathematics and logic. मुझे बहुत अच्छे से मैथमेटिक्स आता है, but where you have to apply what? How to apply it logically, what is the correct part that you have to do, everything is very important, right? So it's a combination of mathematics as well as your logical skills. That is a combination of your aptitude. Fine. Now, as you see on the right hand side, something is written, key to success, right? I'm giving you a small key to your success, whichever exam you're appearing, right? So the most important thing that you should know is, first and foremost, problem recognition. If I don't understand where this question is from, what this question is about, nobody or none of you will be able to understand what technique you have to apply or what rule or which property you have to apply to solve it. So the most important thing is problem recognition, right? And this can only be developed through practice, right? That's what we will do later on. But for today, this is the most important key. Followed by the second one is your speed. See, if I try to solve a question for half an hour, is it going to help me? I have to solve, let's say, 50 questions in an hour. And if I'm solving only the first question for half an hour, is it worth it? No. So the most important thing is your speed. You have to accelerate your speed. Now, the next question coming in your mind is how to accelerate your speed, right? The answer is over here. With practice only, right? Without practice, nothing is possible. Mathematics is a subject wherein without practice, you cannot do it. Like for the theoretical subjects in your curriculum, you must have that is read them, you must have by heart them. Not all those different techniques can be followed, but not in case of mathematics. Arya, please don't do that. Please, no writing on the whiteboard, please. Fine. I hope you understand what I'm saying. Now, moving ahead, these are the most important things that you should understand. That is problem recognition. And the second and the third part is interrelated. That is speed as well as your practice, right? Nobody can help you if you don't have a combination of these two. Fine. Now, we will develop it gradually. Aaj ke hi din I don't want you all to solve it in a minute, right? But we have to develop it. Now we will see a few questions related to a small topic, and it is a very common topic in each and every exam. You give any competitive exam, this question or the question related to this topic has to be there in your, right? It has to be there in that question paper. So the first thing that you have to understand whenever I say time and distance, yeah, okay, fine. So no issues, Arya, it's okay. So now please tell me, whenever time and distance, when you see this name, what is that comes to your mind, which you have learned in your school days? Please, can you tell me? What is that has come to your mind immediately when you see time and distance? Can you tell me? What is something that must be striking related to mathematics, please? So what is that you must be very like, okay, time and distance, yes, ma'am is saying something about this. Okay, so now the very common thing I said about school days, right? I'm not going into anything else. Now, can I say distance is directly proportional to time? Can I say so? And can I say distance is directly proportional to speed? So if I say so, you must have heard distance is equal to speed into time, correct? So this is something that commonly you must have heard. And then depending on this, the second thing, yahi use karke, can I derive the next part? And from this, can I conclude speed is equal to distance upon time? And from the same above equation, can I conclude the next thing? Time is equal to distance upon speed. Can I conclude the next two parts only if I know this much? Can I derive the next two parts? Can I derive it from this? Yes, that's it. And you need nothing other than this. If you know this, you can now solve any question. This is something that you already know. Now, students, is the main thing, that is the application of all this. In whatever questions you see in your competitive exams, you are just going to do the application of it, right? So depending on this, the final conclusion, can I say speed and time are inversely proportional? Right? What is the meaning of inversely proportional? If speed increases, time needed to cover the distance decreases. If the speed decreases, the time needed to cover the distance increases. That is, if one quantity increases, the other decreases, right? And vice versa. So this is how we find speed and time are inversely proportional, right? So directly proportional now is very clear to you. If this, that is, first distance increases, time increases. Distance increases, speed also increases, right? So they are directly proportional to each other. Now, depending on this pattern, this is the same thing which I spoke about right now. Now, there are few tricks. Students, I told you right now, I have to solve some questions. That is, if I have to attempt an exam, I have to solve it quickly in less than a minute, or just a one question in a minute, right? That is our agenda. So if you have to get my ultimate agenda of solving the questions in 1 minute, you should know few tricks. You should know some shortcut ways of solving them. And one of them is, if same distance is traveled at different speeds, right? If the speed is S1 and let's say the other speed is S2, right? So if I travel the same distance, that is, I'm traveling from Mumbai to Pune, and now whatever is distance between Mumbai and Pune, it is the same distance. Will it change anytime? Will Mumbai move further? No, they're going to have the same distance. So if I have to cover the same distance at different speeds, then can I conclude the average speed will be twice S1, S2 upon S1 plus S2, right? So these are those shortcut tricks that will help you to do it in a minute, right? So just remember, for time being, I will go to its application, right? So that time you will tell me what I have to apply. Please be alert. Fine. Nobody is going to sit idle and just look at the screen. You have to be alert. I can take anybody's name anytime. Now, so if the same distance is traveled at different speeds, let's say you are traveling from Pune to Mumbai, but you are traveling at 3 different speeds, then the average speed is given as thrice S1, S2, S3 upon S1, S2 plus S2, S3 and S1, S3, right? So these are a few tricks through which you can solve them quickly. I will tell you how to apply them as we move gradually ahead. Moving to the next part, the most important thing that you should know is the conversion of time and distance, right? So even I know most of the exams allow you calculators. That's what I know, right? Even if you are allowed, you are not allowed. So still the most important thing is this conversion. The most important thing that you should know is 1 kilometer per hour is equal to 5 by 18 meters per second, right? So now you'll say, ma'am, we have calculators. We don't need all these conversion factors. Yes, but there can be times when you are appearing somewhere where calculators will not be allowed. So then this is something that you should know, right? So this is how did I derive it? 1 kilometer divided by 1 hour. That is 1 kilometer per hour. So please tell me, how much is 1 kilometer? If I ask you, 1 kilometer is equal to how many meters? 1 kilometer means how many meters? Everyone? Oh, great. Nice. So it is 1,000 meters? Yes. 1 hour If I want to know it in seconds, I'm asking in seconds. 1 hour in seconds. Yes, great. It is 60 into 60, that is seconds, right? So can I conclude from this? That is, let's say this gets cancelled, right? So can I write here 10 by, or let us further go ahead, right? And can I say it is 5 by 18 meters per second, right? So this is how it is converted. It is written in this way, 5 by 18 meters per second, right? So this is how it is converted. And same happens over here, right? So now this is important whenever you solve a question related to time and distance. Now, seeing this question, can you just tell me what should be the output? What is the time needed? How much time is taken to complete his run-up? Anyone? Anyone who can tell me what is the time needed to complete the run-up, right? In cricket, you must be watching the World Cup going on, right? So in that, you must have seen the bowler is running from a long distance behind that umpire, and then he comes there and just throws the ball. So can you tell me what is the out, that is, what is the time needed? Anyone idea how to do it? So what you have to do is, can you see here, this is my distance? Yes, very good. Most of you have told me the output, correct. This is the speed. Abhi to maine bataya what you have to do. So if I know the distance, if I know the speed, can I find the time? Answer is yes. But the small thing that you have to consider is, this is in meters and this is in kilometers per hour. Can you see there is a difference in the units? So your agenda or your first thing that you have to do is convert it into same unit, right? So if I have to convert it into same unit, can I write here, as it is 36 kilometers per hour, the converting factor is 5 by 18, right? So can I say into 5 by 18, this will give me the output in meters per second, right? 18 ones are, 18 twos are. So this is 10 meters per second. Now I have distance in meters, I have the speed in meters per second. So can I say time is equal to distance upon speed? Yes. And can I write it as 100 meters upon 10, that is equal to 10 seconds, right? So this is how you apply it. And this is just an idea about how to apply the things that you know. And the most important thing through this question, I want to tell you, always check, though you are going to do the calculations through calculator and all, just check this units. This units is very important. Always remember, whenever you do the calculations, the units should be same. Fine. Now, please read the question and let me know whatever I told you in the last few slides. I have to apply something over here. Can you tell me what was the shortcut trick, or what was the property or the formula that I can apply over here to solve it in less than a minute? Can you all think? Please let me know. I have shown you what is to be used. Can you tell me what is to be done? Quickly, come on. Any idea that you can tell me? Something that we have just seen 2 slides ago. पिछले 2 slides में you have seen that. Okay, everyone is telling me the final answer, but what did you do? Can I say it was the same thing? Yeah, the answer was correct, perfectly fine. Only Aishwarya gave me whatever I needed, right? That is, I need to know what application you did. See, 4 kilometers is the correct answer, everyone, great. But what was the application, right? So if there are 2 different speeds given and the person is covering the same distance, then can I say it is the average speed is equal to twice S1, S2 upon S1 plus S2? Yes, Mohammed, correct. Right? So great. So now this is how you apply whatever you learn. You are in this phase of life that you have to apply whatever till now you have learned, right? So we are doing the same thing. So this is what we have seen till now. Yes. Speaking about something called as relative speed, one of the important things of this topic is relative speed. If I consider two objects, can you see both of them are moving in the same direction? Yes. So when these two objects are moving in the same direction, their speed is, the relative speed is equal to v1 minus v2, right? That is, you have to subtract their speeds, right? So always remember, whichever speed is bigger, let's say v2 is bigger or v1 is bigger, right? Whichever is bigger, you have to subtract the bigger speed, right? That is bigger speed minus the smaller speed. Always remember, this is what you have to do. You will not get a negative answer ever. If the two objects are moving in opposite direction, right? Both the objects move in opposite direction, then in this scenario, you will say the relative speed is the addition of these two speeds, that is v1 plus v2. So please remember, this is also a very important part of your time and distance topic. It forms the basics of time and distance, right? Can you please tell me what exactly I have to do over here? This is how you get the questions, right? Now just recall, or now you have to apply the technique that we have learned earlier. Anyone who can tell me? Okay, let us start. If two trains, right? There are two trains. Let's say this is the first station, that is station A. Let's say this is station B. The train starts at 7:30 a.m. from this station, right? The speed is 60 kilometers per hour. The other train, which starts from the station B at 7:30 a.m. and it is moving at a speed of 90 kilometers per hour, correct? So this is how the two trains are moving. Now they have given the distance between the two stations is 930 kilometers. Even the distance is given to me, right? So I know the distance between station A and station B is 930, correct? This is what is given in the question. Now I have to find at what time do they meet, as the two trains have started from their respective stations. We have to see if they have met over here. Let's say they meet over here somewhere. So what is the time when they meet? This is what is asked. How do we solve it? I told you, nothing other than the basics that we have learned till now. How to apply them. This is what you have to understand. I know you know all the basics, but how? Now, you all know time is equal to speed by distance, right? That is, distance upon speed is equal to time. Yes. What is the have I used anything now? Just see here. Have I used anything? No. Please tell me, if the distance I know, right? What is the distance? It is 930. Okay. What is the speed? But I'll just make a small change over here. I'll say relative speed. Why relative speed? As both the trains are traveling, that is moving objects in opposite direction. If you all remember or recall, please understand, two objects moving in opposite direction, right? That is v1 plus v2. We will add up their speeds. So can we do the same thing over here? Yes. How do we do that? Time is equal to distance upon speed, the relative speed. Yes. So can I say it is 930 divided by speed of the first train, which is 60, speed of the second train, which is 90. Now you have to tell me, should I do the addition or should I do the subtraction? Because the two trains are moving in opposite direction. Yes, perfect. So you all have understood what I have to do. Everyone gave me the correct answer. So can I say it is 930 divided by 150? Right? So can you tell me what is the output over here? What do I get over here? Anyone who can tell me what is the final output that you get? Yes, you get the output that is, or you can say, whenever you solve this, the final concluding output you get is 7, right? It is 7.2 hours. What is the meaning of that? Now this, yes, we have solved it, sorry, 6.2 hours, right? We get the output as 6.2 hours. But can you see here, I have written something as 6 hours 12 minutes, right? Because the question demands the output to be something related to PM, AM. I have got the output as 6.2 hours. So now we have to convert 6.2 hours into minutes, that is hours and minutes, right? So what we do over here, we keep this 6 hours as it is, and we write this as 0.2 hours. Now we want to convert this 0.2 hours into minutes. If you have to convert hours to minutes, you have to multiply by 60, right? So this will be now in minutes, this 6 hours as it is. So can you tell me 0.2 into 60 is what? It is equal to 120 and a decimal point over here. So can I say it will be 6 hours 12 minutes? Can you see? This is what I get. Now, this is something that they expect you to know, right? This is a very basic thing that you should know. Now, the second part is important. As the train has started from their respective stations at 7:30, so please tell me, after 6 hours and 12 minutes, what will be the final timing? Can you tell me what is the final timing now? It will be 13 hours and 13.42 hours, right? That is 13 hours and 42 minutes. So what is the meaning of 13 hours? If you consider the 24-hour clock, 13 corresponds to 1 p.m., right? So 13 corresponds to 1 p.m. and remaining is the minutes. So can I say this is the perfect answer that is equivalent or that is corresponding to our output? Can I say that's how you solve it? Have I used anything that is complicated other than the basics of time and distance? Have I used anything? Now, please don't tell me that we don't know what is this, right? So this is something that you have done already in school. So that part we expect you know. Everyone, till this, all well? Yes, good. Okay, great. Nice. Fine. Now, I will just take a small part of this trains, right? There are some questions based on trains, which is a part of time and distance, right? So I'll just show you how it works in trains. Let's assume that S1 is the speed of the train, S2 is the speed of an object, L1 is the length of the train, and L2 is the length of the object, and T is the time taken by the train to come past the object. So in this situation, let's understand, whenever you solve the questions related to trains, you just have to apply your basics, right? So that means in this scenario, there are only 4 cases. And if you can understand these 4 cases, you can solve any question that is asked. right? We'll just understand these 4 cases and then we can conclude. So stationary object without considerable length. Now, if you understand the scenario, what is the meaning of this case A? What is the meaning of a stationary object? What can be the possible stationary objects you might find? The possible stationary objects can be an electric pole. Then the second can be a tree, because it's a stationary thing. I hope you are understanding what I'm saying. Or can I say it is just a man who is standing? He is not going to move from his place, right? He's just standing like a stationary object. So I can say these are a few examples of a stationary object on the stations or related to trains. Now they say this stationary object without length. So now you must be wondering, ma'am, what are you saying? Electric pole has length. Ye dekho. This is the length of an electric pole. This is the length of a tree, right? This is the length of a tree. Or if this is a man, this is also having length. So that's what you must be feeling. No, always remember there's a small thing that you have to understand, and that is you have to solve the questions imagining that you are watching all of these objects from the top view, right? Let's imagine you are sitting in a helicopter and watching them. What will you see, or how you will find these objects when you, if you are sitting in a helicopter? Can I say this pole will look like a point? This tree also will look like a point. This man will look like a point. So can I conclude this all will look like point objects? That is, they will just look like a small point, right? So that is what is the meaning of stationary object without considerable length. All the questions that will be asked related to trains will be solved considering that you are watching them or you are seeing them from a helicopter. That is the top view. So what is the length of the train? The length of the train will be equal to the speed of the train into the time taken to pass this object. Which object? उस train ने इस electric pole को कितने time में pass किया? This train has passed this tree in how much time? This train has passed this man standing in how much time? Right? So now let's imagine this part very well, right? So let us see how it works. Imagine that this is a train, and imagine it is what, or the speed is S1, its length is L1. And there is a man who is standing on a platform. He is a stationary man, because my case says stationary object without considerable length. So this is a stationary object. I'm watching him from the top view. Can you understand? I just said each of the questions are treated as if you are watching from the top view. So how he will appear over here? He will appear like a point, right? Then can you see here? Only the train has passed that stationary object. So how will you calculate the length? The length is equal to, the length of the train is equal to the speed of the train into time. Can you imagine now, after seeing this animation, how the train is passing that object? That is the stationary man, right? This is the first condition. Coming to the second condition, right? All the considerations are same. The second case says stationary object with considerable length. Can you tell me few examples which will fit into this category? What can be those examples? That is a stationary object. It should be a stationary object and it should be a considerable length. Again, a reminder to all of you. You are going to watch them from the top view. Great. Chiranjeev has told me something. Platform. Garima, true. Then second, can I say a tunnel? Can I say a bridge? because these all are stationary objects. I have never seen a platform walking, nor a tunnel moving, nor a bridge also moving from one place to other, right? All of them are stationary. So in this scenario, if you can imagine a platform, this is my platform, let's say, right? This is the length of the platform. This much is the entire length of the platform, let's say L. And you're watching from the top view. What will be visible from there? Only this much part, right? That is, you'll see the length of the platform. And so it is considered as a stationary object with considerable length. Fine. Even if I speak about a tunnel, right? Observe it from the top view. Usko ऊपर से देखो. How it will look? It will look like a considerable, that is a stationary object with considerable length, let's say L, L1, right? So now in this scenario, we have to consider the length of the train as well as consider the length of the platform or that stationary object, whatever is given in your question, is equal to the speed of the train only. Please tell me why I have considered the speed of the train only, because all of them are stationary objects, so they will not have speed. Only the train which is passing the stationary object will have speed. Into time, the time t small t denotes time taken to cover this distance, that is pass through this tunnel or the platform, right? So let's have some imagination about it, or let's find it through this animation. This is a train with speed S1 and length L1. Everyone with me till this? Yes, great. A platform? Yes. It is having a length L2. Now, what is going to happen? Stationary object. Who is stationary? This is a stationary object. And it is with some length, right? That is L2 length. And now this train is going to pass this stationary object. Just see how it is passing. Can you see here? The train has passed the stationary object. So you have to consider L1 plus L2 is equal to S1 into the time needed to cross that platform. Fine. So this was the second case. Coming to the next part, that is the third case, it says moving object without length, right? Can you tell me a few examples which fit into this category again? What is the meaning of moving object without considerable length? Yes, can I say a man walking? Or let's say he is even running, right? A man walking or running. Can I say into this category a man sitting on a bike? Yes, he will, a man sitting on a bike. Did I mention the, I'm considering the bike? No, I said man on a bike, right? So I have to say here, it is a man on the bike. I'm speaking about the man sitting on a bike, right? Or if you know, there are few examples related to fly, right? Or you can say flies. I'm not saying the grammatical meaning of fly is flies and all that, right? I'm saying fly means the insects they are speaking about, right? So there are few, in some exams, they even consider that and then they ask you a question, right? A fly was sitting on a person who was at a speed of so and so, right? So in that scenario also, it can be considered. So what we have to do? Then in this case, as the moving object is not having length, so we will just consider the length of the train is equal to S1 plus minus S2 into T. Why have I written this plus and minus? What is the meaning of this? Anything that you can recall from the previous slide? Why must have I written S1 plus minus S2? What does that mean? Yes, perfect. Very good. It means relative speed, correct? What is this relative speed? How will I decide if it is in the same direction. So what should be my sign? What sign should I have? S1 minus S2. And if they are moving in opposite direction, what should be there? What should I do with the speeds? S1 plus S2. Perfect. Very good. Right? So I hope you are understanding what is the meaning. I have written it over here. Now it totally depends on the question that is asked to you. Fine. Now, let's imagine or let's see how it works in this situation. This is my train with speed S1 and length L1. There is a platform, right? And this is a man who is standing on the platform right now. But he will start moving, or he'll start walking, or let's say running, right? He is having his speed as S2, and both of them are moving in opposite direction. So now, can you see this man is moving, right? In this situation, they are moving in opposite direction. So what should I write over here? L1 is equal to S1, S2 into T. Please tell me, whatever you saw in this animation, according to that, what should be the sign over here? Everyone? Yes, great. Plus, yes, why? Because they are moving in opposite direction. That is why I have written plus. Good, perfect. And coming to the last and the concluding condition, only 4 conditions you solve any question that comes in any exam. Moving object with considerable length. Can you tell me a few examples of this? What can you consider this? Like, what can be that moving object with considerable length? It can be a car which is moving. It can be a truck, or let's say a container, or any moving vehicle, right? Any moving vehicle, can I say? Or it can be a second train also, because that train is also moving, right? Yes, that is 2 trains, or it can be a car, truck, container, a vehicle that is moving. Anything it can be. In this scenario, can I say the length of the train? This is the length of the train. This is the length of that object, which can be a car, truck, container, or a second train, anything. I don't know what it will be in the exam. And then the speeds again will be considered as the relative speed, right? So please remember, this will be considered, we will consider their relative speeds, right? So let's imagine the same scenario through this example. Let's say the speed is S1 and the length is L1, right, of the first train. There is another train having speed S3 and a length, it has a length L3. Fine. Now they are moving or they are crossing each other, right? So as they are moving or crossing each other in opposite direction, at least for this scenario, it will be L1 plus L3 is equal to S1 plus S2, right? Because they are moving in opposite direction, we will consider their relative speeds as S1 plus S2. Is it clear to all of you? I have tried to explain it in the most easiest way in which you can consider the condition, understand this animation, and then now we have to just apply it where whatever question is asked to us, right? So the application will be the only part that is remaining, right? So as you can see here, can we try applying it over here only through this example, right? Just apply whatever you have learned. Let's say there are 2 trains of same length and they are going to cross each other, right? They are going to cross an electric pole first and then they are going to cast themselves, that is cross each other later on. So first condition, or in this first situation 1, can I say the trains will be passing the electric pole, right? There are 2 trains, they are passing the electric pole in 12 seconds, right? The same electric pole. For your understanding, I'll draw this electric pole, right? Now let's say this is the first train It is going to pass this electric pole, let's say in 12 seconds. And this is the second train which will pass this electric pole, let's say in 20 seconds. So we will consider this first scenario, right? That is, I'll write here in short, trains passing the pole. Can I say it is this scenario? Yes. Now, how do they move ahead? Right? So let's understand that as the two trains are passing an electric pole, which is a stationary object, right? So I told you, which is the situation? This situation one is same as case A. According to that, the length of the train we can have, the speed of the train we can have into the time needed to cross the electric pole, right? What is the length of the train? I don't know. What is the speed of the train? First train? I don't know. And it needs 12 seconds to pass the electric pole. So can I conclude from this? S1 is equal to L1 by 12, right? The first thing. And from the same scenario, can I say the second train, L2, right? It is mentioned here there are two trains. So L2 is equal to S2 into T, right? The speed of the second train. So from this, can I say the time needed to cross the electric pole is 20 seconds? So the concluding part is S2 is equal to L2 upon 20. Now, if you read the question very carefully, it is mentioned same distance. So depending on this, can I write L1 is equal to L2? The same distance is said. Can I write so? Yes. So instead of writing here L2, can I write here as L1 by 20 itself? Can I do that? Please tell me. Can I change it? Instead of writing L2, can I write it L1? Yes. Why? It is mentioned. Now, in situation 2, what is given in situation 2? Please read the question carefully. Okay, a small request. Do not write whatever I write in this way. Situation 1, 2. This is for your understanding, right? Now, what is there? How much time do they need to cross each other while traveling in the same direction? That is, when they move ahead, somewhere they are going to cross each other. The two trains are going to cross each other. So the time needed to cross each other, we have to find it out, right? That is train passing another train, right? The first train passing the second train or the other train. So according to this scenario, can I say it is similar to our case D? This was same as case A. I have taught you 4 cases, A, B, C, D. So I'm just showing you how I am applying them in different scenarios. So L1 is L1 plus L2 is equal to S1, S2 into T. Please quickly tell me what should be the sign between S1 and S2. Should I say the relative speeds will be added or they will be subtracted? Please read here carefully. I have marked it over here. As the two trains are moving in same direction, it will be minus. Yes. So as you see here, the lengths are same. I will write it as L1 plus L1 is equal to the speed is L1 by 12. The speed of the second train is also L1 by 20, right? Where did I get it from? From 1 and 2 over here into the time needed. So can I say this becomes twice L1 is equal to L1 into bracket 1 by 12 minus 1 by 20, right, into T. So this L1 gets cancelled. And here, can I just write it? Twice is equal to 1 by 12 minus 1 by 20 will give you 8 by 240, right? What did I do? I have taken both the LCMs, or you can say I have just multiplied them and got a common answer, right? So it is 8 by 240 into T. Or can I conclude here T is equal to 60 seconds? Do you all agree? See, you can do it with your calculators. If not, this is a simple mathematics that you can do, right? So 2 into 240 divided by 8, or 8 ones are, 8 threes are 24, right? So 2 into 30 is 60 seconds. Have you understood how I have told you all the 4 basic cases? Depending on that, I have just applied them in the question that you can see in your exam. Everyone till this clear with the idea of what is to be done when you are solving such questions, right? Everyone clear till this? Perfect now? Okay, great. So now here is how we will move always ahead. That is, we will first understand the basics and then its application to whatever type of questions are asked in our exam, right? This is what we will follow whenever we go ahead with the sessions, fine? So would like to conclude on this part. This is what I do. This is how I go about. I start from the scratch and then I gradually increase the level as per your examination. That is depending on the type of your exam. Fine. So thank you so much for being so patient, replying to me immediately or responding to me in the chat box. Thank you so much for that active and very good active participation. Fine. So thank you so much. I'll hand over to, yes, I'll hand over to ma'am.
Yes, thank you very much, ma'am. Now we'll have a discussion session. But before that, we would just like to take you all through